we had the bases already the same. So here's what I'm going to do. I'm going to force the bases to be the same in this problem as well. Now to do that, I've got to think about what smaller base could be raised to a power that's either going to give me 216 or 36. So I'm really thinking about getting the same base, right? So this is when knowing your powers of different numbers comes in really handy. Like knowing the cubed of numbers, like up to like 10 cubed, is pretty powerful for you. So here's what we can kind of think about. If you started with, well, okay, I know 36. I know 36. That's a power of 6, right? So I could write 36 as 6 squared. Well, that's a good start. Is 216 also a power of 6? That's the key. And it is. 216 is 6 cubed. So it's really powerful there. What if it's not? Then you've got to pick a different base. So what's nice about these is that they are both also powers of 2. So we could do 2 to some power on both sides as well. If it's not, if you can't find a base that's the same, we're going to actually talk about how to solve that later in the year. It's going to have to be solved using a logarithm, and that'll be a topic for later in the year. So we will talk about that. But for now, you're going to be able to set up so that both bases are the same. So I'm going to just rewrite this equation. Instead of 36, I'm going to write 6 squared. Instead of 216, I'm going to write 6 cubed. But I have to be careful here. So it's 6 cubed, but I still have that power that I started with originally, which is negative 3x. So pay attention. This right here is 216, okay? But I still have to write the power that was there originally. So now I've got a relatively easy equation, right? It's kind of like what we just talked about. The bases are the same on both sides, so we know that 6 raised to some power has to be equal to 6 raised to some power, so the powers have to be the same. So that gives me a really nice and simple equation that I can set up to solve. Okay, so I don't want to do any more in that section because I do want you guys to be able to try some of these on your own, but did that help? And give me a yes or no in the chat. There were a handful of you that asked for help on that section. Okay, awesome. So, next up, let me get back to the right screen here. We had a handful of people asking about 13 through 16. So let me find a problem in there. Yeah, so 13 through 16 are absolute value problems. I'll do just kind of a basic one with you just in case you forget the process for absolute value problems, how to solve those equations, or maybe you just never learned the process. You know what, I'll do 16. There we go. Okay, so let's talk about 16. We've got 2 plus the absolute value of 1/2 m equals 43 over 18. All right. One of the keys with an absolute value is understanding what it means. So if I ask you to tell me what the absolute value of 2 is, what I'm asking you to think about is what is the distance from 0 for 2, right? So the distance from 0 for 2, that's 2 units away from 0. So that's just 2. But if I turned around then and said, well, now tell me the absolute value of negative 2. What's interesting about this is that here's negative 2. What's the distance from 0 for negative 2? Well, it is also 2. So what this tells us is that every absolute value has 2 possible, or how do I say this? For every distance from 0, 2, 3, 4, 5, there's 2 possible absolute values it could have resulted from. So we have to think about that when we're setting up our absolute value equations. We have to kind of keep that in mind. There's actually two possible numbers that I could plug in for m that are going to give me the same absolute value. So I need to start by first getting the absolute value part of that equation totally by itself. So don't touch anything inside the absolute value. Just get the part between the bars on one side of the equation by itself. So in this problem, the first thing I would have to do is subtract 2 from both sides. Okay, so I've got the absolute value of 1/2 m equals, now 43 over 18 minus 2. That's like saying 43 over 18 minus 18 over 18. So that's going to be 25 over 18. I'm just not spending a lot of time on talking about how to add and subtract fractions. I assume that you can do that. Now that I've got it down to the absolute value, I'm going to think about the fact that there's actually two possible numbers that could have given me that value. And here's how I set this up. I'm just going to take that 1/2 m, and it's sort of like when you solve a quadratic. So when you solved quadratics, you had like x squared equals 4. You knew that when you took the square root of both sides, you could get a positive result or a negative result. It's kind of the same thing here. I'm going to think about it just being the positive result. And then I'm also going to think about, because there's a second solution, 1/2 m equals negative 25 over 18. I'm just going to think of it exactly like I would think about it if it were a quadratic. There's two possible answers. And if you know anything about the graph of an absolute value graph as it compares to the graph of a quadratic, this will kind of make sense. So then from there, you could just solve that equation, or those two equations, and you're going to get two solutions. So for all of the absolute value problems, you've got to set up two equations after you get the absolute value part, the part between the bars, on one side by itself. Okay. Did that help? Just helps if I get feedback from you to let me know if I need to do any more from there. Good. I'm seeing some of you say yes. If you have any other questions, don't hesitate to ask. Just put a question mark in the yes. See, we're going to graph this year. We're going to do a lot of graphing this year. We're going to be graphing a lot of different families. It's going to be really cool, actually. Adama, I'm recording this, so you'll be able to watch it later. I'll post it to our classroom, so you can go back and watch it again. All right, and then looks like 25 through 26. I'm sorry, Ashley. Is it possible to have a negative absolute value? So yeah, that's a great question. So you have negative absolute value of 2. So what that means is, think about your order of operations. You do what's inside grouping symbols first. So the first thing I would do is I would take the absolute value of 2. Now what this negative in front really means is that you're multiplying by negative 1. So what this really means is that I would have the absolute value of 2, which is just 2, but then I would have to multiply that by negative 1. So it's actually giving me negative 2 as a result. Now I'm not saying that the absolute value is negative. What I'm saying is we did something to the absolute value after we took it. It's a good question. All right, so let's take a look at something like 25 or 26. So I want to be careful here because they are very different problems, I think. I'm debating on if I even want to talk about those right now. So here's what I'm going to do. I'm not going to actually talk about either one of those right now. What I will say is this. Remember the structure of solving for a variable when you have multiple variables is to try to get all of the terms that have that variable on one side and then attempt to factor it out. That being said, I'm gonna allow that one. I'm not gonna say anything about that one right now. I want to let you struggle a little bit more with it between now and Thursday, and then hopefully between now and Thursday, we'll have someone that has figured out a solution. And then I'm gonna ask probably the if someone does figure it out, that they present. That would be really awesome. And there were just a couple people up in the 7 and 8 section. So let me just address some problems there. And I think that's just, maybe not having a super ton of comfort with fractions. So let me kind of get you started on that, and I will let you finish. So let's use green. I haven't used that yet. So we've got, let's look at 7. -4/3 times, so here's what I find when I'm solving equations like this. The mistake I always make is I drop a variable. Like almost every single time. I just forget to write a variable because I get so wrapped up in the fractions that I just forget there's a variable involved. So don't lose your variables because that's a common mistake for me. So the first thing I would do here is I'd probably distribute, so I get rid of all the fractions. So I would have -4/3 times 5/2 r, -4/3 times 2/5. So that's going to give me -20/6r. We can reduce that. That might be helpful. We'll come back to that in a minute. Minus 8/15 equals, so we have 13/4 times r, minus, so that's 50 plus 15 is 65/12, minus 27/8. Now and I think you guys have answers for most of these in the document that we sent you, so you could check your answers as you go. And like I said, I'm not going to go through this whole process right now. I'm going to let you kind of take it from a point where I stop. The first thing I would try to think about is, what's my common denominator going to be here? And if I remember correctly, it's not small. Does anybody know what the common denominator is for this one? Have they worked through it? $120, $60. So I'm seeing 120 and 60. So let's think about this. So 120. Well, let's talk about 60 first, because that would definitely be nicer because it's smaller. Adam changed my mind. Okay, so it is 120, I believe. Because 6 will go into 120. How many times? 20 times? 15, I think, is 8 times. 4 would be 30 times. 12 is 10 times. And 8 would then be 15 times. So we have a common denominator. So you have a couple of ways of approaching this. For now, it might be easiest if you just rewrite every fraction so that it actually has that denominator, which means I'm going to have to do some heavy duty work here. Okay. I'm going to have to multiply this fraction, what would we say, 120 by 20/20. I'm going to have to multiply this fraction by 8/8. This one by 30/30. So I'm just trying to figure out I'm sorry if that's small, what would make each of my denominators be the same, okay? I'd have to multiply this one by 10/10, and then this one by 15/15. So what ends up happening is you're going to get all of these fractions that have the same denominator. At that point, you can do one of two things. You can start combining like terms and then just move on. Or you can multiply the entire fraction by 120. Now, I don't want to go through all of that process because you're going to need to probably bust out a calculator here for some of this. But for example, just to give you an easier one to think about, if you had something like 2x/5 plus 3/5 equals 17/5 minus 15, let's say 16x/5. So let's say you had that equation. Okay, and that's a similar situation that you're going to end up with on the previous problem. So with that particular situation, if I multiply everything in this equation by 5 over 1, so I'm multiplying the equation, both sides, by 5, what ends up happening is, and I don't know if you guys talked about this in Algebra 1. Did you talk about the idea of giant ones in Algebra 1? Okay, so that's a somewhat familiar idea for you. What you do is you create a bunch of giant ones. You create a giant one here, 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 and here. And the beautiful thing about that is that it ends up getting rid of all of your fractions. And you can solve your equation. That's the process you're going to have to use on that previous problem. Does that help? For those of you that are struggling with that section. Okay, good. So one of the things I want you to remember is whenever possible, please give us an exact answer. So that means give us an answer that's not a rounded decimal. Okay, so fractions are always preferred. That is my go-to. I prefer to see fractions as answers. It's just a more exact way to represent your solution. And it's important because when you get to later mathematics, you might have to use a solution that you found in one problem to solve another. And if you are starting to round, you're going to end up with answers that are starting to compound on that error. There's a rounding error there. And so the more you round and the earlier you round, the less accurate your answers will be at the end. So I just want you to get in the habit of always giving your answers in exact form, unless I tell you can otherwise. All right. So we did talk about these. What I want to do for you next is have you just go back in and start to make some corrections. So so you have a couple of options here. You can either just focus on today's assignment and just make corrections to this assignment, or you could go back